Here we're evaluating logarithms with other bases. And there's a formula you can use that works really well on your calculator. Basically, log base n of m is the common log of m divided by the common log of n. Or you could even use the natural log. It really doesn't matter what base you use, but your calculator only stores these two bases, the common log, which is base 10, and the natural log, which is base e. So the formula, you could just use your calculator to do that, but I would like to show you how to do it logically, and then we can do some with the calculator as well. I want to show you both ways. So logically, remember that a logarithm is an exponent. So here I'm looking for a log, and I know my answer is going to be an exponent. But what exponent am I looking for? Well, my base is 3, and I'm asking myself, what exponent, if I take 3 and raise it to that power, is going to give me 3? That's how you analyze these logs. What exponent, when I raise it to that power, or when I raise 3 to that power, gives me 3? Well, that's obviously 1. Okay, 3 to the power of 1 equals 3. In the next one, what exponent, when I raise 4 to that exponent, gives me 16? Well, 4 squared is 16, so I know that the output of the log base 4 of 16 is 2, because this is the exponent on 4 that will give me 16. Now my base is 2. What exponent? This is a little tricky, right? I know that 2 cubed is 8, but I have 1 over 8. And when you take the reciprocal, to get the reciprocal from an exponent, the exponent is going to be negative, right? That's what negative number in the exponent will give you the reciprocal. So 2 to the negative 3 will give me this reciprocal of 8. 2 cubed, or 2 to the power of 3, is 8. So the negative 3 is going to give me the reciprocal 1 over 8. All right, not so hard, right? You're just looking for exponents. Whenever you're evaluating logs, you're just looking for exponents. Here, I'm asking what exponent on 5 gives me 25? That's obviously 2. Here now, what exponent on 6 is going to give me 8? I don't know. That's some odd number, and that's the point at which I'm going to need my calculator to do this problem and this one as well, because I don't know offhand what exponent on 7 is going to give me 100. So I'm going to bring out the calculator, but in order to do that, I have to use this formula. The calculator has only 2 logarithmic functions stored in it. It would be impossible to store all possible log functions because there are infinitely many bases. So you just simply can't do that. But since we have this conversion formula, we don't need all those functions. We just use the 2 that are most used, and that's the common log, which has base 10, and the exponential log, which is base e. I'm sorry, the natural log, which is base e. So those 2 logarithms are stored in your calculator. So I'm going to use this formula. So what I'm going to do then, if I have enough room here, is I'm going to take log base 8 divided by log base 6. The base is always on the bottom. So that's how I remember this formula. The base is on the bottom. I'm taking log of 8, dividing it by log of 6. And here, I'm going to take log 100 divided by log 7. Okay, now log 100 is just 2 because the base of the common log is 10. What exponent on 10 will give me 100? That's 2, but I don't know log of 7 offhand. So these I'm going to have to calculate with my calculator. So let me go ahead and do that. So I'm taking log of 8. And then I'm gonna divide that by log of 6. Now, don't mix and match. You gotta stick with the common log or the natural log. You can do both. So here I've chosen the common log to do this calculation, and I get 1.16 approximately. And then for the next one, I'm taking 2. This time I'm gonna use the natural log. 2, or not the natural log, the common log, sorry. Log 2, wait, sorry, 2 divided by log 100, or no, what was it? 7, sorry. Okay, there we go. So that's 2.37. Let me stop sharing my screen here so you can see that. Okay, so I take log of 8 divided by log of 6, I got approximately 1.16. And so that is the exponent. And then when I take 2 divided by log 7, I get 2.37. So that's the exponent on 7 that will give me 100.